In this lecture, we are going to learn how to perform analysis using Hypermesh Abaqus interface. So we are going to use Hypermesh as our preprocessing software and we are going to perform the analysis using Abaqus. So we are going to follow the problem of this beam bending analysis. So here you can see we have a cantilever beam that is of this length. This is the cross-sectional area for this. And we are going to apply the force of this value, and the unit system in this problem we are going to follow is Newton, millimeter and second. So Newton is for force, this is for any length dimension, and S for second. As we already discussed, for the pre-processing or every meshing or load application work, we are going to use the Hypermesh software. For the analysis, we are going to use the Abaqus software. So now let's go to Hypermesh and start this analysis. So I will go to Hypermesh. So you can see we have this user interface of Hypermesh. So first thing we need to do is select the proper profile. So here if you go to this icon of load profile user, click on this. Here you can see multiple profile for multiple applications. So here first of all we need to go to this option of Abaqus. Now in this Abaqus you will see in the drop down you will see standard 2D, 3D and explicit. So we are going to take this standard 3D and this is an implicit analysis. So we are not going to take the explicit. Now click OK. So it is very important to select the proper user profile. Okay. So after that we need to create our beam. So we are going to solve this problem as three types of problem. First we are going to create this beam as a 1D. Later on we are going to also create this as a 2D and 3D. So first let's start with simple case, that is 1D beam. So to create a 1D beam, as we already know, we need to create nodes. So here I will go to geometry. You will see option of nodes. So first all the nodes will be 0, 0, 0, create. Press F for the fit, and then so length of beam is 500. I am taking the x-axis as length direction. So this is 500, others will be 0, create. Press F. Now you can see both the nodes. Now click on return. Okay, so after that we need to create a beam here. So go to 1D, you will see bars. Now in this bars, one option you will see here, property. So right now we can see we don't have any property, and along with this we need to define material and the cross section. So first let me define all these properties, then later on we are going to create the beam. So click on return. So I will go to this option of hyper beam. Click on hyper beam view. Here we are going to define the beam profile. So make a right click on this empty space, create, standard, go to, we can choose any one option, Abaqus or Hypermesh. Let's say I will select Hypermesh. So we have our rectangular. So let's see where is the rectangular box. So we have solid rectangle. Click on this. So you can see A and B. You can see the dimensions here, insert value. This is 25, press enter, 25, press enter. Okay, once again 25, press enter. Press F for the fit. We need to insert this value, press enter. Then click in this window and press F. Now you can see this is the beam profile. In the right side you will see all the properties of this beam profile. For example, its centroid, local axis, etc. Now once again we need to go to this model view. Also you can define some name for this. Right click, click on rename. So let's say this is my beam section. So this is optional. Press enter. Click on this model view. Okay, after that we have created the beam profile. Let's create the material. So make a right click, create, go to material. So the material is steel. So we are going to consider the basic steel here, and when I click on the steel material, you can see all the info of the material. So here first of all we need to select in the card image, that is Abaqus material. Now we need to define three things. First we need to define the density. So go to density, make a check on this. Now here we have multiple options. So all these options are for when we go to the advanced level of defining the density when it is a variable function. So right now it is constant. So directly go to density, double click on this, insert value 7.85 e raised to the power minus 9. Enter. Now we need to define the elastic properties. So you will see the elastic in this drop down. Click on this arrow. Here you will see E and nu. So E for the steel is 2,1 and 4,0, and nu, that is Poisson's ratio, let's say this is 0.3, and E is the Young's modulus. So we have defined the material properties. Okay, after that we need to create a beam property. Because we have created a profile and we have created a material, we need to make a property that contains both properties of section and material. So make a right click, create, and go to here. You will see property. In this property, give it name. So we can insert the name here. Let's say click on property once again, go to property, insert the name P beam. So it is always good to insert some relevant name. Now in the card image, we need to select the type of section or type of profile. So we know this is a beam profile. So here go to beam. So this is the beam profile, beam section. Click on yes. Now material name, click on this unspecified. Once again click on this. Now we have material, that is steel. Click OK. One more thing we need to define here is the beam section. Click on this unspecified beam section, make a check on this, click OK. Now this property contains both material and beam section. Okay, so after that we can create our beam. Go to 1D bars. We need to select node 1 and node 2. Now in the property, click on this property, select P beam. In the element type, you can see multiple types of element. That is, we are going to select B31. So B31 is a type of beam that takes both transverse and axial loading. And here one more thing we need to select is the orientation of the beam. So you can see X, Y, Z. We have more option like selecting the node property, etc. So we have to make sure that beam orientation should not be along the length of the beam. You can see right now we are taking the length in X direction. So this beam orientation should always be perpendicular to this X direction. So either we can take Y or we can take Z in this case. So it means X is 0, Y is 0 and Z should be 1. Or we can select Y as a 1 and Z is 0. So it will create basically a type of axis that is always perpendicular to the length of the beam. Okay, so in the node A, select node A. In the node B, select this node. You can see a beam has been created. Click on return. Once this beam is created, you can see in the model browser, you will see a new component has been created. Expand this arrow. You can see the name of the component is auto, and this auto component contains the beam. I will click on this mesh. You can see the beam is hidden. Make a click on this once again. Beam is showing. You can also change the color from here. Click on this color, give it any color. You can see color is change. Now I will also give it the name beam. So always give some relevant name. You can see property is unspecified. So make a double click on this property. Once again, select P-beam. Now this beam has both P-beam property and material steel. So in this way we have created our beam profile. So I'm going to save this file as a save in Hypermesh Abaqus folder. Let's say this is my beam 1. So you can use it for your reference.